Okay, stability. What stable air means is that it does not want to go up. Okay, unstable air wants to go up. So this is a great figure. If this is stable air, it wants to go down. There's no reason for it to go back up, right? This is unstable air, it definitely wants to move, right? So stable air does not want to move. Unstable air definitely wants to move. Now we talked about the wet adiabatic rate and the dry adiabatic rate. So we're going to talk about the environmental lapse rate. This is the actual temperature of the atmosphere. And so as you go up, you're going to cool. This is the actual temperature. Remember, dry was 10 degrees, wet was 5 degrees, right? So the actual, or the environmental, is the actual one. It's never quite 5 and it's never quite 10. So you have stability if the environmental lapse rate is less than the wet adiabatic rate. And in this case, you're going to have clear skies, maybe some nice clouds, right? Nothing big, nothing scary, just a nice day out there. Now, environmental instability is the exact opposite. The environmental lapse rate is greater than the dry adiabatic rate. Okay, so unstable, it will want to rise. So as it rises, what happens? It cools, it expands, it condenses, clouds, precipitation. Right? And so you can see in this little picture over here, you're starting to get not so nice cloud. Right? This usually happens during warm months, clear days, and a lot of times it's due to convective lifting. Florida's starting to be explained, isn't it? Conditional instability is the most common type, right? So what happens is it's stable, it's happy-go-lucky, stable, not wanting to rise at all, doing very good, but then, it's clear, couple of clouds. Well, what happens? The sun comes down, beats on the pavement, heats the air above that air starts convective lifting, right? So now we've got unstable. And the convective lifting happens. What happens? You expand, you cool, you condense, you clouds, right? And this happens a lot in the summertime. You get thunderstorms and tornadoes. Okay. So for those of you that are not wordy, anyone picture, here you go. Stable, cool, warm. Unstable, warm, cool. Well, warm air rises, right? Conditionally stable looks just like the stable, but then the sun's like, hey, let's warm up this one part. And so now you have warm, cool, warm. Not very good, right? So how can we change this stability and instability? Well, right, so if you heat this, that'll add to the instability. If you cool this, that'll add to the instability. So you could warm the lowest layer of the atmosphere, and you're going to get this. You could force the air to get lifted by the ways that we said earlier, or you can get radiation cooling from the top. So if you have a cloud up here, it can cool this area around the cloud, and therefore you turn it into an unstable condition. How do you make it more stable? Well, this is stable, right? The Earth will radiate the heat away, especially this happens at night. The Earth radiates its heat away, and so it makes it colder. Temperature inversion can cause a stable atmosphere. Normally we have warm air, cold air, and so the warm air rises, mixing unstable, lovely situation there. But when the temperature inversion happens, you get cold air at the bottom, warm air at the top. Well, everything's happy, so nothing wants to move, and that's why you get that lovely fog and that yellow haze over top of cities like LA, because it's happy. It doesn't want to move. Cold air likes to stay at the bottom, warm air likes to stay at the top, and so you get all of the buildup of the ickiness just sitting there.